Welcome to another video of geometry with special guest, Miss Ovalles.
Hey.
Okay, so remember the axioms of equality. We have 4 of them, and I just put them here as a reminder. We're going to be using them today, okay? So let's look at our first proof. Now, our proofs are going to be about breaking parts of wholes, okay? We're going to be breaking things apart. When you break something apart, you call that partitioning, okay?
Okay, so partitioning is breaking wholes into its parts.
Perfect. Yes, it is. And so that's what we're going to be doing in our first proof. Okay, so let's look at the given. The given says that we know AB is equal to DC. Okay, so if we know that AB is equal to CD, then we have to prove that AC, this whole part here, is equal to BD. And you should believe that just by looking at it, but we will prove it. All right, so right away, you should set up your T-chart in statements and reasons. You should all know what your first statement is and your reason, okay? So the first statement is your given, and the reason is actually given. So I want to prove something about AC and BD. I want to show that they're equal. So what is it that I know about AC? Well, the only thing that I can do to AC is break it down into its component parts. So that means that AC is equal to AB plus, yeah, you guy in the blue shirt, what did you get? Yeah, BC. See, Miss Ovalles, they know. So now, what is it that you know about BD? Well, BD, I'm going to break it down into its components parts. So BD is equal to CD plus BC. That's what I know. Okay?
I see that.
And so what I did was, what is the reason for breaking things apart? Well, we just spoke about it right before we started our proof. And we said this is called partitioning, right? But what I'm really using is the axiom. Don't forget about the axiom. The whole is the sum of its parts. I broke the whole, AC and BD, and I broke it into the sum of its parts. All right, so notice what my goal is. My goal is to prove that AC equals BD. So if I can get these two parts here on the right-hand side to be the same thing, I will be golden. So let's show then that AB plus BC is the same thing as CD plus BC. Well, I already have a BC in both sides. What is it that I know about these two things? Notice it's right here. What do I know about them?
I know that AB is equal to DC.
Yeah, Miss Ovalles, you're on the money. So part 3, right? Part 3 says, right? And so we made that substitution. Well, AB is CD, there it is. And CD I left the same on the bottom. So I left the bottom equation exactly the same. And all I changed was the CD part, okay? Because AB is CD. And the reason I can do that is by the substitution. Yes, it is. And so now what do I finally know? Well, AC is now finally equal to BD, all right? So final statement is AC equals BD, okay? And another reason why that's true again for statement 4 is by substitution one more time. Okay, all I did was substituted. Are we good there? Hope we are. Come to class with questions. Here comes the challenging part, okay? Example 2. Here's our given, and here's what we need to prove. Now I'm going to provide you with the statements, and you will provide me with the reasons. All right, so we know that we break it down into our statements and reasons. We do our first part, and you will give me the reason, right?
This is my given.
Yes, this is your given. And we're not going to give them any more reasons. They are going to come up with their own reasoning. Okay, So this is my second statement. Angle 1 plus angle 2 is 90, and angle 2 plus angle 3 is 90.
Mr. Jimenez, how come they equal to 90? How do you know that?
Well, right. That's what I really want the students to be able to tell me here on the statement, on the reasons piece. I love that you asked that question, but they should be able to determine statement 2 from the given. So see how the given was this?
Right.
We know that this symbol here is very important.
Yes, that means something.
It means something, right? So I want them to give me the reason as to why this is true now. Yes? Okay. Let's give them statement 3. And now I know you wouldn't think to do this, but actually notice that these two pieces are both 90. So I can set them equal to each other using one of the axioms, right? If they're both equal to the same thing, then they're equal to each other, aren't they? What's the reason for me doing step 3? So you do step 3. And again, at home, you do not need to copy this diagram, but you do need to write the T-chart. In class, you'll have the diagram. Let's do statement 4. So now what I did is, well, I trying to cancel angle 2. So I did something to cancel angle 2. And I want you to tell me here exactly what axiom did I use to cancel angle 2. Because now, notice, angle 2 gets canceled. And I ended up with angle 1 equals angle 3. Do you have any questions on that, Ms. Ovales?
Well, how come you canceled angle 2?
Well,
Why couldn't you cancel angle 3 or angle 1?
That's really good question. Well, look, the proof says I want to show that 1 is equal to 3. So I don't want to touch 1 and 3.
Right.
I want to keep 1 and 3. And the distractors are 2 here. So I want to get rid of the 2's. I can by doing something which the students are going to tell us. And part 4 here shows us how 1 is equal to 3. And now they're going to give us a reason for 4. Okay?
Okay.
So make sure that this is your CFU. Make sure you complete this and you have 3 reasons to give us tomorrow in class.